So we are going to talk about objects tonight. So we've probably talked about objects a little bit already. So we already may be familiar with some of this stuff. So it's better just to look at it in more detail, to be honest, because we're going to be relying on objects, especially in the context of DTOs. I don't know if you've ever heard of that term, but they're a short form for data transfer objects. And usually you'll get a payload of objects, whether it's from, the server to the front end or something, or various ways to pass things around. Sometimes it's better to pass it as a package instead of a string or some. So we've been working with arrays that have one values each, but very often you'll get a list of objects or array of objects. Inside of those packages have many details. It's another way of furthering kind of packaging things up, especially when you're dealing with data that can be complex. So we would need a facility to transfer packets of data, so we would use objects. All right, so we can think of these objects, as this kind of filing bin here on the left. Nice visual representation. Actually, some good visuals today, well, in terms of pictures anyways, because some of these topics are complex and you need to kind of visualize them. But we already have a mechanism for storage, which is arrays. But like I said, we need further to have more, we may need more complex data. So we could think of it as like a drawer. Inside of it may have certain things in that drawer, like a filing system or something like that. You may have different attributes in those files, filing system, if that's a good way of looking at things. But basically, this object class represents one type of JavaScript data type. So object is a data type, much like string or integer or those kind of Boolean attributes. It's actually a type in itself, and you use it to store various key collections, so the key value pair, and more complex entities. So right now we've been really, especially with our arrays, and we really just, if we look at the arrays that we've done, have been pretty straightforward in terms of elements, but you'll see there's going to be more of a need for complex data types. And when I talk about complex data types, like if you think about your music interface, we statically hard coded a lot of those data rows and things like that. But you can kind of think of those data rows as a collection of objects. Each row could be represented as an object. If you remember your row, you had something like, band name, album, rating, whatever details were else on there. But you can imagine each one of those attributes could be part of a bigger data structure, right? So you may have 10 rows, which means you would have 10 kind of data packages or objects. And those objects could be in a list or an array. And you could iterate over those and output them. So especially if you're dealing with just a front end and then we're just dealing with arrays, you may need to filter them or add to it, or like with our stack, push pop things on. So we could potentially, build an interface with some dynamic event-driven kind of data. Although our data may be kind of inside the browser, still we can mock. It's basically mocking an interface without a backend, and we can do that by using objects. So in JavaScript, the object is a collection of properties defined as a key value pair. So that's pretty important. It's a key value pair. Just like in our picture to the left, you can imagine a user object, and we have two keys, name and age, and each of them, if you were to look them up, they would have a associated value to them. So each property has a key and a value. The property key is the string, and then the property value can be anything, anything you might need it to be, right? So if you were to create an object, and we've already kind of done this already, it just can be just a very empty brackets, mustaches like that, if you were to call it. But so you can use that object literal syntax, which if you look at that sentence, just that syntax just creates a very empty object. And we've probably done this before. We've probably even used the object literals before. The object literal notation is basically the array of key value pairs with the colon separated the keys and the values. And a comma after every key value pair except for the last one, like an array. So it would look more like this if we have seen this before. So you can easily create this. This is called object literal syntax. And eventually when we get into something called JSON objects, it's just a mechanism for transferring data, but it looks like this. It looks like an object. And when you become very familiar with objects, you'll know why when we get into full stack 3, why that's important, this kind of syntax. So we create it with the key value pair syntax. The snippet shows a person object. So we define a person as a variable. If you notice that we're using the let keyword, we're going to learn about let keyword tomorrow night in ES6. But you basically create this object literal syntax, and if you see there, you know, this should be the first name and last name separated by a colon, and then you have like your data type, right? This person object has 2 properties, first and last names corresponding, John and John Doe, right? So you can see here, these should be strings, but you know, you're not going to have this as a Boolean value or integer. It needs to be a string. So whether or not JavaScript is smart enough to recognize that, that's fine. But just know that this should never be a number or a Boolean or undefined. The key needs to represent something and needs to be a string. So that's how we would create an object. Before we get into that, if we were to look at some code. So today we're going to be going back. It's not really going to be an interface targeted lecture, so we won't be using the DOM too much. So we can go back to this playground and just focus on the JavaScript itself. So if we wanted to, let's look at a couple examples here. So this is the person object again. So if you take a look at that, you can see here we have the person object, and we're going to get into this, how to access these variables. But if we just were to output the object itself, hold on here, console log dot person. If I run this here, you'll see here, I'm just going to give us back this literal tag as we actually had wanted, right? So, but if we wanted to get access to these attributes by keys, you know, we could use the key itself using this is called dot notation by the dot. So we could actually get access to those as well. Of course, we could potentially, let's see if we can do it in this way. Like if we tried to access it like an array, let's see what happened there. So it'd be undefined. So we can't treat it exactly like an array. So we can't, because this is not the same. It could potentially be, we could certainly have an array of objects if we had whatever. We may, if you visualize, may have an array of music albums. And we could have objects inside of there. If we were to output the music keyword here, let's take a look at that. So we can have an array of objects, right? So you can imagine in your project, you may have an array of objects that are quite bigger, and then you may need to iterate over them and then kind of drill down into each property. And you may need to use something like the dot notation to get access to them. There's other ways to actually get into them, but we'll take a look at those in a second. So that's a good way of packaging data up. We're going to get into different ways of creating objects. There's many different ways to create objects. You got to remember that if we quickly wrap it in this way, it's great, but it may not necessarily get all of the, there's a whole bunch of built-in object methods and properties that we may take advantage of, just like we had array and we have string, that, you know, maybe there's a best practice of creating objects to give you all of those other kind of, all those other built-in methods, right? If you use an object wrapper, and we'll focus on that in a little bit, but just know the short form for this is, if you want to create a quick object, you can certainly use an object literal, and that is the syntax like this: key value pair. And again, these types on the side can be anything. They can be You know, okay, sorry. If I wanted to expand on this object, you know, I could say, okay, you know, I don't know, whatever, is enrolled. Could be true, false. You know, you could have it like a date of birth, right? DOB equals new date, something like that. Doesn't really matter what it is on the value side, as long as we are actually, if you can see here, I output it now, it's true, the date is actually like this. Now, if we had something like this and we tried to give the key as a new date, well, let's try to run that and see what would happen, right? It's going to say syntax error, unexpected identifier, because it knows that you're basically going outside of a string value there. So if we tried to actually try to put 100 as the key, let's try that, 1,000. So that actually may convert it into a string if you saw that. So that is actually, you know, it knows smart enough how to what about null, right? Can we have null as a key? Basically, it allows string value of null. So what if we had undefined? Would undefined be a key, or would that break? Undefined is converted to a string. So it'll convert it down to a string. But, you know, you got to make sure that you're not going to name your keys undefined, and you're not going to name them null. You're going to be smart enough, because you know JavaScript is weird. It's going to try to convert it. It's smart enough to know what a key is, how it needs to be distinct, has to need to be a string format. So it's going to try to do its best to kind of convert it. But be smart when you're creating these and make sure they make sense. They're not A, B, C, D, or 1, 2, 3, or whatnot. And just be very careful with the keys, right? Because the keys are how you find your data. Just like in a database, when you have unique keys, the key is very important, right? Because without it, you can't get access to the values properly. All right, so let's do a quick intro on that. I did a bit of intro, and we'll talk about it a little bit more. But let's take a look at another example. Hopefully, you can hear it. Let me know if you can.
To launch a cult skate brand. Honestly, as long as you have a logo.
Yo, what's going on, guys? You're watching JavaScript for Beginners lesson 27, and in this video we're going to have a quick introduction to objects. Alright then, so JavaScript uses these things called objects, and you see objects in all different programming languages, but in JavaScript we use a kind of stripped down, simplified version of them. Now, we've already seen objects in previous lessons that have done. For example, if I make a string, that's an object. If I make a number, that's an object. An array, that's an object. Plus loads of other different things in JavaScript that are also objects. Now, essentially, an object is just a container which encloses data and behavior together where they belong together. For example, if I make an array, that's an object, yeah? And on that array, I can extract data such as the length property, and I can extract behavior such as the sort function, where we can sort the array into a particular order, or the reverse function, etc. So I want you to think of objects like real-world objects. For example, an object might be a car, right? And a car has properties such as its colour or its maximum speed, but it's also got behaviours such as driving or braking or accelerating. Now, in programming terms, these behaviours, we'd call them methods of the object. And remember, methods are just functions. So the behaviour drive would be a function of the car object, right? So imagine our car was an object in JavaScript, right? We could make a new car and store it in a variable, something like this. Say var my car equals new car, right? And that there would create a new instance of the car object. Right, now I can't run this in JavaScript because we don't have an object type of car. If I press enter there, look, car is not defined. But if we did have that object type and we stored it in a variable called myCar, then I could call properties and methods on that variable that we give to the car type. Right, now, for example, myCar.length. I could use dot notation, which is this here. We put a dot after the variable name and call properties on it, such as length, or my car dot max speed. Yeah, and that's going to give us the maximum speed of my car. So we can call properties on it using the dot notation. We can also call functions or methods on the car, which is going to invoke the behavioral aspects of that object. such as mycar.drive, and that would call a function called drive on my car, or mycar.brake, right? These would be the behaviors, or in JavaScript as we call them, the methods of this object. So notice how the methods have these parentheses at the end, and the properties such as top speed don't. That is because these are all properties. They're all bits of information about the car. We're not running any kind of method or function on the car. We're just extracting a bit of information. So we don't need to call a function. Yeah. Now, if we say mycar.drive, drive would be a method or a function of that car, and we call functions, remember, by putting the parentheses at the end. And then if we need to pass in any variables or parameters or arguments, as they're called in JavaScript, then we'd pass them in here, right? Such as, I don't know, 35. That might be how many miles per hour we're going. So that is how we would call properties and methods of an object that we create. Now imagine instead of car, right, because that doesn't exist in JavaScript, we've not made that, we make a string. We've seen that. We can say var myString equals new string. And this is exactly the same way we're creating the car object up there. Okay, so everything applies. So we've made this new string, and we can say myString equals hello. Yeah, we're just giving it, oops, not that. I have to put them in double quotation marks. So we've assigned that string an actual string then. Now we can call properties on this called length. And that's going to give us the length. Or we could say myString dot to lowercase. And that's going to convert it all to lowercase, etc. It was already lowercase, but if it wasn't, we would have done, etc. So this is exactly the same as what we saw for the car example. Okay, so just think of objects in JavaScript as objects outside of JavaScript in the real world. We can do all the same kind of things to objects in JavaScript as we can in the real world, right? We can call properties on it and methods. So we've seen creating a string object. Now, saying something like this, my string2 equals hi there, that is exactly the same as instantiating the myString object right here. It's just a shorthand version of it. We're still creating a new string object, so we can still then call all the same properties, length, or we can call methods such as to uppercase, etc. We can do all the same things with it. It's just that we've used the shorthand version right there. So that is a quick introduction to what objects are in JavaScript. In the next lesson, what we'll do is we'll take the...
All right, so we're basically, you know, we've basically used objects already, like as we saw in this example. We know the dot notation already. We know how to do methods on objects, right? So the difference is there's a lot of object types, and also we're going to be creating our own objects with our own methods, our own behaviors, our own properties and actions. So it's our way that we're creating our own packages in case we need to use them, right? And you know, but to be aware of it, you know, when you do define something like hi there as a string, internally JavaScript's taking care of that, you know, and behind the scenes, the short forms. There's many short forms, just like the object literal, and behind the scenes JavaScript is kind of wiring it up in the same way. But however, we are going to be building our own objects. That's the difference, right? And when we get into objects, we get into you know, object-oriented programming. It gets very complex. Today, I'm going to try to overview it, but I'm not going to get into it in very deeply, because it gets very complex very fast. So at a high level, at least we'll know about it. And then we'll just, you know, like we're basically not going to get too deep into, there's something called the prototype chain, but that right now, I think for this course is not, so we're not there yet. So anyhow, if we wanted to access the properties, we kind of already understand that there's the dot notation, so we already kind of we already know this already. But in the context of our own object, we can use the same type of accessor, right? It's object name and then dot property name. So if we have a person object and we need to get the name or age or date of birth, it is simple as using the dot property name if you know it. If it doesn't exist, then it may throw an error saying undefined. Obviously, if we wanted to access the first name property of that person object, it would look like this: person dot first name. So here we go. We have that example we just previously looked at. Object literal, first name, last name. And when we want to get access to those properties, we're using this dot notation, and we are console logging them. There is another way to get into those properties using an array-like notation. So we know how to access positions of the array. So in the same way, we can also access the keys, but you got to remember here that, you know, just like in this other way here, we look at this here, going back, where was it? Property name. So we need to know the property name, which really is the key, right? So we're basically looking at the object using the array structure with the key property name. We could also call this array-like notation or bracket notation. So again, if we wanted to, it's a little bit, you know, I mean, I would think dot notation is probably cleaner. However, you know that you have this access as well. You can certainly do this in this way. So if we were to take a look at that, we have another accessor, which is the array accessor. If we have an address here, so we have an object literal, we have building number, street, state, and country. So if we wanted to get access to, let's take a look here at this. Same deal if we wanted to console log. If we wanted to get into the street, we could certainly do that as well. Take a look at that. So that actually will output, by the key value pair of street, it'll output the value itself. But we could use this bracket notation here, and I think we wanted to actually console log here. So console log. So we could treat this object like an array, and we could use the street, okay, in that way to output in the same way. So you can see it done 3 times, right? So if we didn't have, so what happens if we had street 2? If we actually tried to return a key that doesn't have anything, it's going to return undefined because it doesn't know the key that you're actually looking for. And what happens if we tried to do like Boolean, you know, I don't know, true, something like that? What would happen then? It would just also give an undefined. So it's basically going to try to look in the object for the property that you are looking for. However, if it doesn't find it, it's going to find undefined. Here's a situation where you may have a space inside of your key, which is kind of, you know, it may happen. It's probably best to, you know, camel case that. And when I mean camel case, do something like this, you know, to not have spaces. But for whatever reason, maybe there was a purpose that you needed that in your array. Maybe you need to print out the keys in a nice format. You know, we could certainly output it by bracket notation. It'll allow us to do that. So if we were to console log address by that key, because it is just a string, so it'll respect the fact that it has, where am I looking at here? My brackets here. Building number. So if I do actually run and output that, it should actually find 936, so it did. But I guess my note here was, you can't really use the dot notation in that sense, because if you try to use the dot notation, like it's basically going to throw an error. And you'll see here unexpected string. So it doesn't necessarily like that, because you can't certainly, because the dot notation is expecting the property explicit like that. So if we were to try to do the dot notation without the quotes, you'll see there that it you know, you can't really have a space, so it's going to give you a weird error anyways. If you walk up to it and try to wrap it in a string, well, it's going to fail then, because that's not the expectation of that dot notation. that, you know, you should actually have the key itself. So, and the key should be in this format by accessing the properties, right? So this is not going to work. So in a way, that would be one benefit of using this bracket notation in case you have spaces or special characters in there that you can't escape. And then readings from a key that doesn't exist, as we already said. If we tried to look up the district here, it's going to give us, okay, well, we're done with this one because this throws an error. So we can basically comment this one out. However, if we did go for the district here, it's going to give it undefined. So any key that's not there, it's basically going to say, well, can't find it. So you're out of luck. You are out of luck. So dot notation, array-like notation, those are the two ways to give an accessor. They're not the only ways. Certainly you could create your own method to return some of these if you didn't want to basically, you know, give an easy way of returning one of these values or multiple values. You could give a behavior that you could trigger. I'll show you that in a second, but so those are two ways you can actually dig into that object. So, but you may need to modify object properties as well. So it's fair enough that it's good, all well and good that we are going to be reading from the object, but many times, especially if you have a data transfer object, and when I talk about DTOs, I'm just talking about data from the back end, or it may not be from the back end. You may have an object floating around your UI, and it may be as simple as you know, let's think of a product or an item that's in a shopping cart. You know, if the user actually had added that item to the cart, you may have, maybe your cart is a collection, some kind of collection, and you have an item in there and you want to track it. You can certainly have a status flag on that item that basically says, well, it's active or not, or it's in the cart, or now it's been deleted, and you can do something what's called like a soft delete. And a soft delete is basically a way of tracking that somebody had deleted something, but has not truly modified the data explicitly. Basically, you can keep a record of what the person had in the cart and what action they may have taken on the item. Right? And that may be good for a number of reasons. Maybe they want to restore their cart. Maybe they want to, maybe for your metrics, you need to know what they added, what they didn't add. Sometimes it's very valuable to know, maybe the person came to the checkout, was going to buy that big item, but for whatever reason decided against it. It's a good way to track inventory and those kind of things. So you'll very often see a soft delete in databases as well, because sometimes when the data is gone, it's gone, and sometimes you don't want that. You just need a marker on it to see, you know, that the data was marked for deletion, and then you have something that truly deletes it after the fact. But anyhow, that's the reason why you might want to change a property. So following example shows an array-like notation to access a property. So we have a person, first name, last name. We want to go and walk up and change that first name before outputting. And that's how you do it. Same way, dot notation for the key, set a new value. So here we go. Here we have our version of the person here. If we go to output it in this manner. All right, so we started with, if we console log out at that time, console log out person before the change. So if we see here, at this point in time, the person is the original value. It's John Doe. We change the first name right here. We output, we see we modified the name from John to Rick. The last name is still Doe. And then after that, we modify the last name to Flair, and we have John, it now has changed to Rick, which still is Rick. The last name is Flair. So you can see that's how we would modify something simply. We'll see later we can actually add things on the fly as well, right? And we can do a lot more. This is basically just showing how to change the properties, but we can do a lot with these objects. So that's changing the properties value on the fly. If you want to add a new property, so here we go. We add a new property. So unlike objects in other programming languages, this is very key. This is so key because this is one of those things in JavaScript that you're not going to see in some other languages like C and Java. So in other objects, such as C in Java, C# in Java, you can add a property to the object after creating it. So on the fly, we can modify the object, which, you know, in the strongly typed language that defines everything up front, you can't do that. You're basically changing a contract. But here, you know, it's basically wide open. Like, it's almost like JavaScript is like the Wild West in a sense. You have a lot of freedom to do a lot of things, which is the reason why there's so many frameworks out there, because basically people just build on top of this and they make their own languages, to be honest. So so you have a mechanism to add on to an object when it's already created. We may not look into that part, but it's actually called a prototype. So there is actually something that you can attach things to in behind the scenes. So, but just know that if you create an object, you can certainly modify it before it hits wherever you need to hit it, or just modify it on the fly. So if we have that same example, where were we here? Change object, add, delete object property. So here, yes, we have that person object that's empty. Actually, what we want to do here is we'll just say, okay, person.age equals to, what is his age? 73. Well, he's up there, right? Console log. So basically, we're adding on the fly, and it's not gonna. As you can see here, the object maintains itself all the way up until this place here where we have added a property to it. Now, if we add it as well, we can certainly delete it as well, and it won't bark at us, which is amazing and problematic depending on where you're looking at it from. So again, if we can add a property, we can certainly delete it on the fly. There's nothing stopping us from deleting it, which again, you're not going to see this in C# and Java. You can't just walk up to an object that's defined, strongly typed, and delete properties. It's crazy. But here we can do it. So we could potentially delete every single property in that object, and it'll allow us to do it. As long as you have the object name and the property, you can delete it. So the following example removes the age. So we had added an age, and now we basically deleted it right in the same step, and it will not bark at us. It'll let us do whatever we want to do. And if that means some really foolish things, then it's not going to complain to us, because it's going to say, well, that's what you want to do. So you can see here we had a blank object here, which was a bracket notation, which was object literal. We had no properties, it's empty. So we added the first name right away, and you can see the object looks like this. We go ahead and we can console log out the object at this point here, person object. So you can see here on the right side, as it changed, modified itself, we added it, and then right away we deleted it. And then we tried to output that property we just deleted. It gave us undefined. So if we wanted to console log the person after that modification, you'll see it has been restored back to its original status. Let's see what happens if we go ahead and delete person.firstname and then console log that. That it probably is just going to be an empty object again. No, what happened? Sorry, delete person dot, and you got to get your spelling right, otherwise it's not going to know where to look, right? So it is case insensitive. You have to be explicit there. So you can see there, now it's empty. So remember, I just did that quickly, right? Lowercase when my key was actually upper camel cased. So remember that, otherwise it may not work and you may run into some issues. So we basically cleared out that whole object, and it didn't bark at us. So like that's just quirkiness here. So if we can add, we can delete. Take that away. You might want to check, in fact, if a property exists before you do something to it, like modify it before you try to call it. So you have a concept of the in operator. So the in operator will check if that key itself is in the person object. So again, if you noticed, the person here, sorry, the first name is not wrapped in a single quote, because internally it'll know to convert it. So it's not a problem if you don't wrap it in, but just know if you're trying to call it from the outside, and sometimes if you're not using the dot accessor, you need to actually define it as a string, because otherwise, if you remember your JavaScript, it's gonna, if you don't define it in a string in the global scope, it's gonna think it's a variable already. It's gonna think it's a global variable or a local variable or something like that. So that's why you would wrap it in that way. So yeah, just remember that, because there is scope that's happening inside of the object, has its own scope, right? First name is encapsulated inside of this object, and we'll talk about that in a second. So you can think of this as an object that has its own scope. Outside of this object, nobody really knows what's in that object unless you know how to access them, how to access the public properties. Otherwise, if you try to output first name outside of that employee, it's going to throw an error, because when you're outside here, it's going to look outside the global scope, right, and try to find that value you're looking for. If you're calling it within this scope, which is employee dot, then it will know to look inside of this scope for that value. So that's why sometimes you have to wrap it in the string, because otherwise it'll know it's a key instead of a variable itself. So here we have an employee object, a literal object with 3 keys, and we just want to check the fact that social insurance number is in employee, which should be false, and whether or not this key, employee ID, is inside of this employee object. So if we run that, we get false and true. However, like I was saying, if we were to console log employee ID in the outer scope, right, that should throw an error or be undefined. See, it's going to say referenced employee ID is not defined. It has no idea what we're talking about. However, if we said employee dot key, then it's going to know exactly what we're talking about, and that's 1. If we try to wrap this in a string, like so, it's going to give an unexpected string because it doesn't know what we're trying to do. However, if we use the bracket notation or the array-like notation, it's going to know exactly, hopefully, what we're trying to do here. Where's my bracket? Like that. So a couple ways to check whether it's quickly in there. It gives a true false. So I'm sure if you wanted to do some logic like, employee ID, if employee ID is in employee, then what do I want to do? I want to do something here. I want to change it then. I want to change the fact that employee ID is now 501. Therefore, when I console log out the employee object, it should change the 501. It should change. Now it doesn't like me for some reason. What happened? Do I have to refresh here? You never know what can happen with these node servers, but however, this one's pretty fast, to be honest, so not too bad. Let's see, run it. So it doesn't like it for some reason. Oh, there it is. Okay, it did like it. Just took a little bit of time there. Okay, so that was good. So it actually, you can see that it actually did modify it, because it did see that it was there, and therefore instead of 1, it changed it on the fly to 501. I mean, we can still get creative and say, if first name is in employee, then delete it. You can certainly do that as well. If first name is in employee, then we can walk up to that object and change it as well. And delete, what do we say? Delete first name in employee, something like that. I actually forget, to be honest now. Deleting a property, delete, okay, sorry, we have to be explicit and say, delete employee.firstname. All right, employee.firstname. So if we run that, let's look at what that looks like. So now we can see we not only modified the object value, we also modified the object by removing the key value pair of the property itself. So, and it allowed it. It didn't throw any errors or anything like that. Now these checks are actually good, right? Because without it, if we basically just try to, without this check, right? If we had this as .ssn, right? We know that it's false already. It's going to give us this undefined error or something like that. It's basically going to say if employee is in, first name is in here, then try to delete it. It didn't actually give us an error because it didn't find it, right? However, it's good to check it though, especially if you want to modify things, because then it'll basically not give you undefined when you go to walk up to it and try to change it. So a bunch of ways to modify and access objects. And we're going to get into the methods in just a second. So I mean, these are kind of just properties, right? If you think of an object as a car may have a windshield, may have tires. These are properties of a car, the body itself. However, the actions or the behaviors of an object, such as driving, speed, drive, braking, those things are actions. So in the same way as an object in that container, we can give it behaviors or actions, and the way we do that is through functions. And we'll get to that in a second. But before I jump ahead there, if you wanted to iterate over an object property, we can also iterate over the keys by using a for-in loop. So we can actually, anytime you're using that for-in loop, just know that you're getting the keys back. You're not getting the whole object. So you have, by key, you can look at the value. So if you see that example there by the person object, if you want to iterate using the for-in, you set the key and then it'll come back as first name, and then you can inspect the properties as you're iterating through all of the different objects. Sorry, the object properties. Now, you could also make this very complicated, not complicated, but you may need to have an array of objects. Say in a music interface, you have an array. You want to iterate over all of those, whatever they are, albums, and then internally, you need to inspect the properties, right? So if you think about it, you're iterating over each row, which is an object. When you get to that current row, you may need to inspect all of the properties, the keys. Maybe you need to find, all the albums that are rock. So you're looking to build a list of all the rock genres, right? So that's how you could do it. You could inspect the object itself in that way. And again, there are easier ways to do this because there are many built-in features for objects that even makes this easier for you. But again, just know all the tools in your toolbox that you may need to use, right? So we have an object called courses. I don't know what I was doing here, but anyhow, I said the title was George Brown. The URL was georgebrown.ca, and I had tags, which is an array. So you can see here I have not just a mix of, so I have a structure, and inside the structure I have another structure, which is an array. So you can see how this will start to get complex, because you could have an object that has a nested object inside of it, which may have a nested object inside of it. So your objects can get complex, right? And you may need to traverse and dig into your objects, depending on the need of your system and how the complexity that you may need your data to be. So here you can see quickly, what did I do here? I outputted the key. And then what else did I do here? So let me see here. What was I trying to do? I think I'm just outputting the key here at this point in time. There's no values, right? I think I was thinking of something else. So if I'm just outputting, yes, what I was doing here. So output the constant, the key. So the first key was, okay, the key and then the value. So if I got title, so I have the title key, which is here. Okay, that's what threw me off. And then the value is George Brown. And then I iterated again through the URL and found the URL, and then I did this array-like notation. I got the value George Brown.ca. Now what screwed me up was this array here. So when I hit tags, I outputted the tag, and then I outputted the whole structure, right? So if you wanted to further iterate through this, you could check the key. If the key was tags, then iterate through. You see how it can get a little complicated there? I mean, you could certainly check, okay, is the key equal to, tags or something like that? If it is, then you could do another, it's gonna look messy, right? You could do another for loop and iterate through that entire array another for loop, and then output that, right? You could do it for every or something like that. But I don't want to mess up. I don't want to mess you up right now when you're looking at this. So just know that it can get complicated. It can, depending on your system, right? So so that's how you iterate over object properties. There are, again, other built-in methods. I'll leave it to you to kind of, and we may talk about them, I think, in part 2. Some of the built-in objects, built-in methods, sorry, of the object itself, not just your object. So on that note, object methods. All right, so as we were trying to establish that, you know, kind of the academic, we'll get into some theory here. We'll also get into some long-winded, well, not long-winded, try not to do too long-winded definitions, but, you know, it's good to know them. So if we were to read it, an object is a software unit of variables, which are properties, and methods, which are functions. Again, with JavaScript, when we're talking about methods, they're actually functions. In other languages, methods are just, they're called methods. There's no, so those terms are very, you know, they get mingled, but inside of a class or inside of an object, when you have a function, you would refer to it as a method. And that's not just in JavaScript. When we deal with objects and we deal with object-oriented programming, it's so vast. It's basically, it would be something like mathematics, right, or something like that. Like it's basically transcends any language. It's basically a concept that is used in any programming language you may run into that is object-oriented based. And when I say, and again, when I say object-oriented based, it's reusability and it's a way of thinking. There certainly is static procedural languages, which are kind of old school, or maybe not old school, but they're not as popular. Like COBOL was a procedural language, and we'll talk more about that in a minute. But yeah, anyhow, there's differences in why you would want to do this, but it's an overarching concept. So when we talk about this, just know methods are the internals of an object. So, all right, that was a lot. So the objects are often used to model the real world objects, like we said, in everyday life. So an object method provides the only way to access data. So if we have a Tesla right there, now I simplified this picture because there was actually another level to this, but we're just dealing with the object itself. And the object is a car, and the object has a model, which is the Tesla. It has properties. The properties are color, properties are sunroof. You know, does it have a sunroof or not? That could be a Boolean value. In fact, the model name Tesla is a property itself. The methods, now the methods again are the actions of the behaviors. So you have a method that could be horn or steering. That's an action. So two separations there. Properties is more static, right? Color is a color. Method is more something like an activity that's happening, right? The horn is not always on, it's off, right? Steering is, right? It's basically something active. So objects have actions. These actions are represented by functions. So in JavaScript, they're called functions, but we know the object's method when we're talking about the objects in general terms. The generalization of objects have methods. When we get specific in terms of JavaScript, we call them functions. Again, the more you use it, the more you talk about it, you'll get it. Maybe code helps, I don't know. Here's a snippet. You have a person object literal, which is empty here, and we assign a function in this way. So there's a couple ways of setting this up, but here's one to show you. So it's empty, we're walking up and we're adding a property here, a key value, which is greet. We're just adding it, but we're assigning it instead of to a value or string or array, we're giving it a function like this. So we're basically saying that when somebody triggers this property, it'll know to invoke internally the function. So we have a bit of interactivity with this object now. So we can quickly just say person.greet and it'll fire this function, hello world, which is great. And we can use that to build off of for some other things we may want to do with that. Another shorthand way of looking at it is, you may not want to do step by step. You certainly can do step by step. You may want to, when you build your object literal, put it internal in this way, right? You just have to remember that you're not using the equal sign, because this is when you're assigning things outside. Again, object literal, key value pair. Key value pair has colons with a comma. So as we're defining it, we put a comma. The next one is the key name, colon, the value with a comma. And then if we want to add a function, that's fine. We can certainly add a function inside of there. If we have no further keys, then we don't put a comma, and then we're on our way. Right. Right, so we had a couple examples on that. So where are we here? Object methods. So here's how we simply invoke that. So if I console log and copy this to my REPL, yeah, in the same way, we can do it in this fashion. I'm sure we can also delete that if we wanted to, or add, if we wanted to add something new or delete it in the same way. It's not a problem. We could certainly delete, I'm sure, person.greet if we wanted to. And if we tried to console log, what would happen here? I don't know. It's probably going to give us an error or undefined. It's going to say it's person.greet is not a function because we deleted it, of course, because that worked. But anyhow, this is the long way to set it up. And I think this is the inline way of setting it up. So, or this is another way, by reference. Okay, so this is another way of doing it. We can also do it in this way. So you see here, we did it in one line here. We basically sorry, where'd the rest of my function go? I collapsed it. All right, so we can also do it in this way by reference, right? So we can define a function up here somewhere, and then when we get to this line here, we invoke it. We just basically pass it by reference. You can do that. So you don't have to do it in one line. You can certainly do it in that way. So if we run that in the same way, that's fine. Now what we were trying to get at before is if we wanted to, instead of do all this stuff outside, you could certainly define it internally. So greet equals function, and the function is whatever you want it to be. Console log hello world, hello, right? However, if we don't assign it, this other one can float outside, if you notice, because that is the outside scope. This is the inside scope. So if we run this, we should expect hello, because we didn't do anything with this. So again, there is an example of scope happening. We have two functions that are called greet. You would think that this one would overwrite it, but because this is in the inside scope, sorry, the global scope, it's basically as if it doesn't exist internally here, right? So we could have defined above. If it was hoisted anyways, it would be up there anyways. Same deal. However, if we decided to, let's see, we decided to assign it, it's probably going to look up top here and run it. So actually, let's see here. We assigned it. Okay, we assigned it. What did we do here? Person.greet. What would happen here? Hello world. Okay, so we basically overwrote this function. It's just confusing because this one is named the same thing, right? So, but this doesn't have to be. This could be called hello, right? Hello, and you could certainly assign this as hello, right? And then you can kind of overwrite whatever is here in that same way. You could do that, right? You could also leave this as null. You don't know what you want to do with that one until you assign it in this way. Down here. So there's different ways of there's many different ways of setting this up, right? Some people just would rather put it inline, keep it nice and contained inside of here, and then they don't really have to worry about going and assigning anything outside of the object, right? They would just assign it in one line and keep it nice and clean like that. So, you know, nothing wrong with either of those ways, you know, because sometimes you may want to dynamically change your object, and it's not a problem. So, but anyhow, there's many ways that we know of assigning things and declaring things and all that. So So now we have scope, and we're going to learn about a keyword called this in 1 second, and we'll break up my talking here before we wrap up this session with another. Let's listen to somebody else talking, and then we'll take a break and do our labs.
All you need to launch a culinary empire. Tools you claim everyone has in their kitchen.
Yo, what's going on, guys? You're watching JavaScript for Beginners lesson 29, and in this video we're going to take a look at the this keyword. Alright then, gang, so in the last lesson you saw me do something like this. I created an object called mycar2, and I gave it some properties and a function or a method right here, and then we called one of those properties and the method down below. Right now I'm going to take this one step further and introduce the this keyword to you, because it's quite important as we go further down the line in creating objects, right? And we're going to delve into that a little bit deeper later on. For now, I just want to introduce it. So what is the this keyword? Well, it's quite a complex, abstract idea, but essentially the this keyword refers to whatever object currently owns that space that you use this keyword in, right? So if I just say console.log, oops, this, at the root of my document, right, that I'm not in any kind of object or function or anything here, I'm just at the root of my document, and I'm going to console.log this to see what it is, right? And if I refresh, it logs the window object, right? So right here at the root of my document, the window owns the this keyword, and if I was to console.log this anywhere on the top level or in some kind of anonymous function or something like that, this would refer to the window object. However, right, I'm going to cut that, come back up here and create a new method called test here, and this is going to be a function where we're going to log the this keyword like that. Save that, and then I'm going to call it right here mycar2.test. Alright, so now let's refresh over here, and this time it logs the object mycar2, because these are all the properties, right, and the method right here and here of the mycar2 object. So that's what this right here is referring to, and that's because in this context, within this object, this is owned by this object, right? Likewise, if we had another one, let's call this mycar3, console.log this, and then we'll say mycar2.test and mycar3.test, right? So it's going to log it out twice. Save and refresh. This time we get two different objects. Yet the properties are the same, but if we change this one to Sean and save again, refresh, now we can see that it's logging both objects. So right here, this refers to this object because mycar3 owns this context, and up here this refers to mycar2 because mycar2 owns this context. And you might think, well, instead of saying this, why can't I just write out mycar2? And yeah, you could do if you wanted to, but then if you were to do this, copy and paste it down here, change this to 3, you'd then have to go in and change everywhere you've referred to mycar2 to mycar3, and it might not be once, it might be 10 times, and each time you create a new object like that, you're going to have to do that. So it's a great time saver, and it's also great for when you're creating constructor functions. All right, and we're going to get into that in the next lesson. I'm not going to talk about it now. I just wanted to introduce the this keyword right now. Okay, so this could be used for a method instead of test, because we wouldn't have a test method normally. Let's create something a bit more exciting. Let's say log driver. Yeah, and this is going to be a function where we're going to log the driver name. So we'll say console.log and then string driver name is, and we'll concatenate this dot driver. Yeah, so remember, in this context, this is owned by mycar2, so this would be the same as saying mycar2.driver, which is the NetNinja. So this dot driver, semicolon, save, and oh, we need to call it mycar 2.log driver. It's recognized it there in IntelliSense. Then we'll call it using the parenthesis, save that and refresh, and this time we get it right here. So this is where. All right, guys, so that is your introduction to the this.
Yes, right. So this keyword is very important in any programming language, to be honest. So it may seem straightforward to you right now, but it's very powerful, because when we get into objects, we can have many copies of the same, not the copies, instances of the same object. So you need, and when I mean instances, it means that each object is its own instance, and it needs to know about the internals of itself and not care about its siblings or whatever the other copies of the object that are out there, right, floating around. Instances, sorry, not copies, instances. So it needs just to know about itself, and it needs to be able to internalize and report on what has changed inside of itself. So this keyword is contained within the object itself, and it doesn't know about the outside world. It only knows about the container itself. So it's very important. This is very big, and it's, again, another general concept that is used throughout programming. And the reason why is because typically methods need to access its own stored data, and it needs to be able to reference to itself. So when it says this, it's a reference to itself. So you may need to want to return the full name, or maybe you need to return the full name and last name. You don't want to have the user or programmer to keep typing those dot notations all the time, because think about it. You could have 100 properties, and you may need quick functions to return details on a car object. Maybe you have a car and you want some output on the diagnostics. The diagnostics could be temperature, engine temperature, the tires, right? How the whatever, if they're flat or not. I forget what that ratio is. All these different metrics, there may be 5 of them you need. You can just call a function saying get diagnostics, and it'll know to calculate it and return it back to you without having to program through trying to do all those calculations externally, right? You would hope that if the object is created right, all those calculations are inside of the object. You can't see them. You just know that you can call them, and you can if it's written well, you can expect that when you say get diagnostics, that all the work is done inside. In a black box, I'm just calling it from the outside. I expect it to work. Much like any of our document APIs that we've used from the web docs, we assume they know what they're doing, and that when we call it, we get what we need. And we don't need to know any more than that, right? So to the outside caller, in many cases, he doesn't need to know how you calculate it. But however, you're coding this, so you'll know both, right? So for instance, if you needed to get the first and last name, you can just create a function get full name, call it from the outside. It returns internally the full name, last name. Then they don't have to do the dot notation from the outside, right? So again, if you also had, well, let's look at this here. Where's this keyword? So same deal, right? Now this is really simple here. It's just a first name, last name kind of deal. You may have something like a shape. You may have a rectangle or some kind of shape that says calculate the area internally in the object. You may want the calculation to happen. You don't want to have to do it on the outside, right? So here, John Doe gets returned. I like that because I don't have to do anything. Here it could be a lot more than this. It could be a middle name, right? I don't have to sit here and console log, every single property that I might want to get. Already I'm misspelling it, right? First name. There could be 100, like I said, there could be 100 properties in here. I don't want to do this because that's not efficient, right? So again, internally keep this stuff. The keyword that lets you access these properties that it knows about in its scope is this keyword. All right, so that's a lot to take in, but it's a good introduction to objects. So I'll recap that in a sec in this slide here. So an object is a collection of key value pairs called properties, A property key is a string. The value can be any valid value. You can use the dot notation. Dot looks like that, the dot, or the array-like notation, which is like the brackets, the array, to access those properties. You can also delete a property from the object as much as you can add one on the fly. We have the in operator, which checks if it exists, the properties in the object or not. If we want to iterate over those properties, there's a for in as well. And then if we want to add activity behavior to this object, actions, we use functions, and they're called methods. Inside of an object, they're called methods, but when we write the methods, we use the function keyword or the other ES6 type of ways of doing it, which is arrow functions, which we'll learn tomorrow night. And then another very important thing is that this keyword that inside the method accesses its own properties. When it says this, it's like myself. I know internally my own properties, right? All right, that's a lot to take in for sure, no doubt. So let me quickly just stop that recording, and then